Hello everybody, welcome to Guidancee Education channel. We will see the topic that is discussed in this video. We are continuing class 11 physics thermodynamics. In this video, we will be deriving an expression for work done in adiabatic process. But before we start the topic, please watch the video completely without skipping so that you understand all points clear. And if you think the video is useful, do like the video, share the video with your friends who may also be benefited, and also leave your feedbacks as comments in the comment box below. If you have not yet subscribed my channel, do support me and subscribe the channel now, and also press the bell button and all button for notification of more videos like this. Thank you very much. Come, let us see the topic. Derivation of work done in adiabatic process. We will see that. We have already derived a formula for calculating work done in isothermal process. If you have not yet watched that video, click the I button in order to watch that, okay? Remember, in adiabatic process, the system cannot exchange energy or matter with the environment. Let us recall the formula. Delta Q is equal to delta U plus delta W. Here, delta Q is 0. Because it is an adiabatic system. The process is adiabatic means the system is adiabatic. It cannot exchange heat. So negative delta U is equal to delta W. That is expansion work. I will explain. Delta Q is equal to delta U plus delta W becomes 0 is equal to delta U plus delta W. So we shift delta U to the left hand side. So negative delta U is equal to delta W. This is expansion work. That is, the system is doing work on the environment. So we have kept work done positive. But from where does the system get energy? It is obtained from internal energy. The internal energy becomes negative. That is, change in internal energy becomes negative. The initial energy will be more, final energy will be less. So negative delta U is equal to delta W. So in adiabatic expansion work, internal energy decreases. For isothermal process, PV is equal to nRT is a constant. For adiabatic process, we accept a formula without derivation. That is, PV raised to gamma is a constant K. Our syllabus does not demand proof for this formula. So we simply accept this as such. What is this gamma? It is the ratio of the specific heat capacity of gas Cp by Cv. We have already learnt that gases have two specific heat capacities. One is at constant pressure and the other is at constant volume. These are the two. So from this equation, we can get the expression for P. For an ideal gas, P is equal to K by V raised to gamma, which can also be written as kV raised to negative gamma. We will need this for the derivation. So keep it in mind. We have seen that Cp is greater than Cv. Therefore, gamma, which is the ratio of Cp by Cv, will be greater than 0. That is, gamma will be greater than 0. It will have some value. I hope it is clear. Now, for isothermal process, P1 V1 is equal to P2 V2. What happens in the case of adiabatic process? P1 V1 raised to gamma is equal to P2 V2 raised to gamma. We will continue. An ideal gas is taken from P1 V1 T1 to P2 V2 T2 adiabatically. We know work done for adiabatic process is equal to PV raised to gamma. It is a constant. From this expression, we can get the expression for P. P is equal to KV raised to negative gamma. Now we have to find out the delta work done for the various steps in the process, starting from initial, that is W1, to final, that is W2. Work done for the initial step, delta W1 is equal to P delta V1 raised to gamma. Work done for the final step, that is delta W2 is equal to P delta V2 raised to gamma. These lines represent the work done for the stages in between the initial and final stage. But we are not representing the expression for calculating the work done for these intermediary steps. We just show the work done for the initial and final stage because we are going to integrate the whole thing. Total work done, that is work adiabatic, is equal to integrating all delta W from initial to final, that is 1 to 2. Substituting for work done, it becomes integrating P delta V raised to gamma limit 1 to 2, that is initial to final, for work done here, which is again equal to integrating kV raised to negative gamma dV raised to gamma. From where these expressions came, we have substituted for P. P is equal to kV raised to negative gamma multiplied by delta V raised to gamma. I hope it is clear. K is a constant, so it need not be integrated. It is taken out. Then the rest is integrated. So integrating V raised to negative gamma delta V raised to gamma limit 1 to 2. Now we use the formula. Integrating x raised to n is equal to x raised to n plus 1 by n plus 1. So applying that, we will get k integrating x raised to n is equal to v raised to negative gamma. V raised to negative gamma plus 1 by negative gamma plus 1 into delta v raised to gamma, which is equal to k v raised to negative gamma plus 1 by negative gamma plus 1, the whole from V1 to V2. This is for delta V. This is equal to k V2 raised to gamma plus 1 divided by negative gamma plus 1 minus V1 raised to negative gamma plus 1 divided by negative gamma plus 1. We are multiplying the whole by this k. K into V2 raised to negative gamma plus 1 minus k into V1 raised to negative gamma plus 1, the whole divided by negative gamma plus 1, because this becomes common. Okay, we will continue. I'll carry it over here. K V2 raised to negative gamma plus 1 minus K V1 raised to negative gamma plus 1, the whole divided by negative gamma plus 1. Let us recall K is equal to PV raised to gamma, which is also equal to P1 V1 raised to gamma equal to P2 V2 raised to gamma. This is for adiabatic process, okay? K V2 raised to negative gamma plus 1 will be P2 V2 raised to gamma into V2 raised to negative gamma plus 1 minus P1 V1 raised to gamma V1 raised to negative gamma plus 1. Because in this case, K becomes P1 V1 raised to gamma, the whole divided by negative gamma plus 1. This is equal to P2 V2 raised to gamma minus gamma plus 1. That is, we have added up the exponents minus P1 V1 raised to gamma minus gamma plus 1. Here we have to minus this. Therefore, these two quantities get cancelled. What remains is P2 V2 minus P1 V1 divided by negative gamma plus 1. We know PV is equal to nRT. Keep this in mind. Work done is equal to P2 V2 minus P1 V1 by 1 minus gamma. Because here it is minus, here it is plus, so we just reverse that. This can be written as work adiabatic is equal to 1 by 1 minus gamma into P2 V2 minus P1 V1. Now we will substitute for P2 V2 and P1 V1. From this, for P2 V2, it is nRT2. P1 V1, it is nRT1. So, nRT2 minus nRT1, the whole divided by 1 minus gamma. nR is common in these two quantities, so it can be taken out. Work adiabatic is equal to nR divided by 1 minus gamma, then T2 minus T1. What is T2 minus T1? Final temperature minus initial temperature. That is delta T. For adiabatic expansion work, delta T will be negative because for adiabatic expansion work, delta U is negative. That is, it decreases. So we have derived an expression for work adiabatic. If you have benefited by this video, like the video, share the video with your friends, and also leave your comments in the comment box below. If you have not subscribed my channel yet, subscribe my channel now and support me, and also press the bell button and all button for notification of more videos like this. Thank you very much for your support, and we will meet in the next video with another important topic like this. Till then, bye. Take care.